The security situation was such that it was very difficult to get chlorinated water to the refugees in Greystone. The sanitation was horrible. Very rapidly you had severe dysentery sweeping through the population, outbreak of cholera. And my first thought was that is the perfect application for something like the HydroPack.
This is a HydroPack. Inside this HydroPack is a sports drink. This is an 8 to 12 hour pouch. It just hydrates overnight. This pouch, when it's fully hydrated, can be up to a half a liter of water. It can be brackish water, it can be water from a sewer plant. And our product simply is immersed in that water supply. It'll self-hydrate and it'll give you a perfectly clean drink.
We brought 24,000 individual HydroPacks into Haiti. I know they work. I make them, I test them, but to see them in the field and to hand them into the hands of little ones, this little bag of juice in a straw, and watch their face light up. They're a kid and they got Kool-Aid. That's what they thought, that I had handed them a little package of happiness.
What happened in Greystone is not all that different from what happened in Haiti in terms of the dire conditions and the dysentery that quickly sweeps through these areas that have no sanitation, no clean water supply. The HydroPack, it's ideal for disaster relief for that first 10 days. It's lightweight. There's a tremendous logistics savings compared to bringing bottled water. So imagine the money and the savings that you'd bring to a relief situation, the speed with which you would deliver the supplies. It's very simple to use. Children can figure it out, no problem, very quickly. And the purity level is amazing. This simple little pouch delivers the same purity as a multi-million-dollar RO bottling plant.
We're looking for unique ways to take care of water problems that were just too difficult for other technologies to treat. And Forward Osmosis came along and became a very viable way to treat unique, difficult wastewater problems. Forward Osmosis is how water goes from the ground in mud and dirt up through the roots, up through a tree, up to the leaves and the fruit of a tree. How your cells stay hydrated in your body is an osmosis process. The cell walls are membranes and they allow water to pass through back and forth.
So this is actually allowing Mother Nature's forces to work for you rather than trying to fight it. The cellulosics technology is the heart of the membrane, and the membrane is made in such a way that it has small pores which only allow water to pass through, but no other materials such as salts or sugars or bacteria, viruses, they cannot go through that membrane. And cellulose acetate is a beautiful polymer to accomplish the manufacture of such membranes.
The membrane is key to what we do. It's the engine that makes the forward osmosis process work. If you don't have a membrane, you don't have a technology. And the cellulose materials that we use inherently likes water. Eastman has made cellulose material for us that meets unique specs that we need for forward osmosis to be successful. And Eastman's role has been to help us to identify what those specs are and to help make sure that they meet the quality standards that we have set in order for us to make this membrane.
The long-term vision is to apply the technology across a broad category of industries where there's a very specialized need for water filtration, where waste streams are difficult to concentrate and traditional technologies have not proved as successful as the customers would have liked.
This is a product that needs to be there on day one of the disaster relief. In Haiti, we had enormous difficulty in moving the product from our plant to Haiti, and it didn't arrive until 10 days after the earthquake struck. And that's a problem of planning and incorporating the technology into global strategies for disaster relief.